Okay, so first of all, welcome Shiv to the class. This is Shiv's first class, and for the kids, Shiv is the only new kid. There's one more child who is supposed to join. His name is Om. So for the kids who join for the first time, right? The message for you all is that when I'm teaching something, my focus would be only on making sure that you guys learn the concepts and not be busy taking notes, okay? Because whatever I'm teaching, you don't have to take notes for that. Everything is getting recorded except you guys, okay? So me and the board is getting recorded, and I'll put the video of that in YouTube so that you can refer to it. So don't worry about taking notes. Don't get stressed out about missing something which is taught in the class, okay? You will have everything at your disposal after the class. And see, there are some problems that are contagious in nature. So Shiv had his video turned on. As soon as he saw that everybody else has turned off their video, he also turned it off. Okay, so but again, based on your comfort, keep your videos on so that we can make eye contact while we are learning something. Okay, so today we are going to talk about probability. So we started probability in the previous class, and we learned some of the basic concepts of probability. We talked about a little bit about the Venn diagram. How is that helpful? So we'll continue on that front, and we will learn about addition of probability, multiplication rule for probability, and then we'll go to permutation and combination. And all these must be sounding little cryptic to begin with. No? Okay, that's good. So for Om, maybe you might think that okay, there are a lot of loaded words that the teacher talked about, but these are not loaded. Okay, when we go through the concepts, when we try relating that, you will see a lot of practical relevance of what we're going to learn today. So yeah.
Do we need a calculator?
I hate calculators. Okay, so what I mean by that is, you guys have the luxury of using calculator at a very young age. First time I used calculator was when I was in engineering college. So we'll rely on ourselves more than calculators. I'm not saying that you don't have to, but keep it as your last resort. Okay, so probability, chance of something happening. Yeah. Mm-hmm. Now, everybody who has dealt with tossing a coin, rolling a dice, you know that it's an event. When you roll a dice, you can get a number from 1 to 6, right? Say, is that okay? You would have seen a dice, right? Which has 6 numbers on 6 sides. When you roll it, you can get any number from 1 to 6, correct? I would wait for acknowledgement to come from you guys. So if I'm talking about a dice, I'm talking about a cube-like thing which has numbers imprinted on each side, right? Om? Yes, not Om, same. So when you roll a dice, you cannot predict which number comes. So probability or chance of any number happening is equal. You can get a 1, you can get a 2, you can get a 3, so on and so forth. So any number, the total number of things that you can get is from 1 to 6. Probability of getting a 3 is 1 out of 6. Yeah. Likewise, when you toss a coin which has head on one side and tail on the back of it, when you toss it, you can get a head or you can get a tail. So you have two options, head or tail. What is the probability of getting a head? It is 1 out of 2. This part is okay, everybody? Now we are talking about what happens when I have one event happening versus the second event happening. Meaning, let's say I have the same coin with the head on one side and tail on other side. If I'm tossing it once, I can get a head or a tail. In the first go, this is my first attempt, I can get a head or a tail. Or in probability terms, I can say probability of getting a head, let me say probability of head is 1 out of 2. Probability of tail is 1 out of 2 again. Now, when I toss it for the second time, this is my first attempt, okay, attempt 1. Now, when I'm tossing the same coin one more time, Again, same thing. Probability of getting a head is again 1 out of 2. Probability of getting a tail is also 1 out of 2. So far, no confusion. All simple, easy sounding stuff. Now I'm saying, okay, I want to toss the coin twice. I want to flip this coin twice. Or let's say, okay, I want to toss, this is my first toss or flip, whatever you call it. And this is my second toss. Same coin. What is the possibility of getting a head and a head?
1/4.
That was quick.
1/4.
1/4. How?
Because the
one half times
probability of the first toss is 1/2 getting hits, and the second toss is the same one. So you multiply the chances and you get 1/4.
Okay, so you guys are faster than me. So you said, okay, getting a head. So we are trying to figure out the probability of getting a head and a head. So you said 1/2 and 1/2. That was quick, but why? Why 1/2 and 1/2?
Because it's not asking for the combined. No, it's asking for the chances don't change because you're doing one after another. So it's still gonna say 1/2 and 1/2. It's still 50 for head and 50 for tails.
Okay. Siv, you have a different explanation for this?
1/2 because sample space is 2, so 1 out of 2 is 1/2, and then head again is also 1/2. So you multiply to get the probability.
Okay. So as I keep saying, all my kids are much more intelligent than me. Now let me give you guys a very lame example here. Okay. I have one coin which I tossed. I can get a head or I can get a tail. Correct? Now, first time when I got a head, I can get my second. Okay, let's see this one. First toss, I got a head, let's say. I can get a tail or a head for the first toss. Meaning my first toss gives me head, second toss can give me tail or a head. So there are two possibilities. So with my first toss being head, I can get tail or head. Similarly, if my first toss is tail, I can get a head as well as a tail. Correct? What was the question here? What is the possibility of getting head and head in both the toss? This is the only possibility. Which is, the total options are 1, 2, 3 and 4. What is my possibility? It is 1 out of 4. Now we are correlating it. So it looks like probability of head was 1/2, and in the first toss, and probability of head in the second toss was also 1/2. So it seemed like a multiplication of these two. Now you extrapolate that and think about 3 tosses. 3 tosses, okay? Because we are trying to generalize this. And this generalization is going to go a long way for us, okay, when it comes to probability. So that's why I'm trying to do that. Now, assume you had 3 tosses, okay? So when you got head in the first toss, you can get a head in the second toss and you can get a tail in the third toss. I have fixed the first 2 and then just contemplating the third option. Now, so when I have first 2 as head, the other 2 possibilities I'm talking about. Let's go to second possibility. When I have a head and tail, again there I can have tail and head in the third one, right? So we talked about 4 possibilities. Now, if my first one changes, see, look at this. Are there any other possibilities that we have missed? Only with the first being head fixed. Head being fixed, the other 2 flips has given me these possibilities. Same thing, I can replace this 4 with tail and I'll get the same combination. Yeah. Now if I ask, what is the possibility of getting a head and a head? I'm essentially talking about this one, which is again 1 out of 8. Now you look at this. Getting ahead is 1 by 2. Getting ahead in second attempt is also 1 by 2. And getting ahead in third attempt is also 1 by 2, which multiplies to give you this. So 1/2 times 1/2 is actually a derivation from what we have observed here. So now the thing is, if somebody just plays with you and says, okay, fine, I have 5 coins that I'm tossing, okay, together. 5 coins. 1, 2, 3, 4, and 5. What is the possibility of getting all heads? You'll say, okay, so basically first one's head is possibility is 1 by 2, 1 by 2, 1 by 2, 1 by 2, 1 by 2. Multiply it all. And you get, this is the possibility of getting all heads in 5 toss.
132.
Yeah. I mean, that calculator will do. I'm not worried about it. But is that making sense to everybody? Dev, Dhanushri, Sev? Yeah? So we'll take this concept forward, and this will become one of the building block of how we are going to deal with probability going forward. Now let's look at 2 different types of events. One is dependent event, one is mutually exclusive event. Now let's not get lost in the mathematical calculation of it. Let's first try digesting it. What are the scenarios of a dependent and mutually exclusive event? Exclusive. And bear with me if I make a spelling mistake. I don't have F7 here. Yes.
For dependent, it's like you're drawing marbles, but you don't take, like you draw marbles one at a time, but when you don't put back the marbles, you just leave them out, and that's dependent. And then mutually exclusive would be something like the coin toss.
Correct. So in English, if I don't go to math, mutually exclusive is when one dependent has no bearing with the probability of second event. One event has no correlation. I teaching math versus somebody teaching science, mutually exclusive. I don't treat that guy as a competitor for me. Yeah? I mean, there's no competition as such, but I'm still saying so. When one event has no bearing or correlation with the second event, that is when you call it mutually exclusive. And then there could be hundreds of examples. Tossing coins, rolling dice. You roll the dice 20 times and you got certain results. Rolling it 21st time has no linkage with what has happened in first 20 rolls. Yeah? Dhanushri, Dev, Shiv with me? Okay. So when you're talking about any event, if that has no bearing with what has happened in the past or what could happen in future, that guy is very independent. And that kind of event is called mutually exclusive. You can think of hundreds of examples. And another example that David gave, right? That let's say if I have, this bag has 3 blue markers, 2 red markers and 1 black marker. If I put this in this bag and if I'm blindfolded, I'm randomly picking up one marker. This is red. I had, let me keep doing the math simultaneously. So this bag had 3 blue, 2 red and 1 black marble. If you did not look at what I picked up, if I was randomly picking up one of the markers, the possibility of me getting a red was 2 out of 6. Total number of markers were 3 plus 2 plus 1, 6, and the possibility of getting a red was 2. If there was $1 million prize for picking red in the first go, I would have got $1 million this time. Unfortunately, that was not the case. But yeah, this was a gamble. I was blindfolded, I randomly picked one and I got a red. So this is how all the casinos work. I am pretty sure none of you have seen the casinos, but you would be knowing how it works conceptually. So where there is a possibility, a probability of something happening, and based on your luck that given day, you can win a prize. And 90%, 95 or 99% of the people lose. So it depends on your day whether you are among that 1% or 99%. I have been always among those 99.99% who end up losing in casinos. I've been twice. Alright, so coming back to the point. So probability of picking up a red was only 2 by 6 in the first go. Now if I'm talking about, if I let's say put this marker back here and then say, okay, now I'm going to pick up another one. What is the possibility of me getting a red this time?
1 in 5.
So out of 6, 1 I had already picked up. Now what I'm left with is only 5. Just 1 second. Who is it? I'm left with only 5. So what is the possibility of or probability of me getting a red? I can get a red in the second go. Okay, I can get a red in the second go. It could be 2 by 5 provided I did not pick the red in the first go. And if I picked up red in the first go, then my probability of getting a red is 1 out of 5. Am I making sense to everybody? Dhanusri, Dev, safe, everybody? So here, what happens in the second chance is dependent on what happened in the first go. Yeah. So these are the scenarios when you say this is a dependent event. These are dependent events. If I would have picked up a marker and put it back, and then I would have done the same magic like what I was doing before, then these are mutually exclusive because I'm putting it back. If I'm removing it and then changing the overall count of markers that I'm left with in the bag, then all the events are dependent events. This is conceptually clear, right? Nobody has any problem with this? No? Dhanusri, Dev, safe? Nobody? No confusion? Okay. So far a decent job is done by the teacher. Now let's move on. So we have just looked at what is probability, what do we mean by the independent event and dependent event. Let's talk about adding probabilities. Now let's look at a dice that I want to roll. Okay, I can get 1. Probability of getting 1 is 1 out of 6. I can get a 2. Probability of getting, this is for 1. I will give it a technical name. Probability of 1 is 1 out of 6. Probability of getting 2 is also 1 out of 6. Probability of 3 is also 1 out of 6. And so on and so forth. Okay. And probability of 6 is also 1 out of 6. Now, if I say, what is the probability of getting a 3? You will say, don't ask me this stupid question. It is 1 out of 6, as you have rightly mentioned here. If I tweak my question a little bit, what is the probability of getting 3 or more?
Four out of 6. No. Yeah,
4 out of 6.
4 out of 6? Yeah. 4 out of 6, meaning basically you're saying that, okay, what is the probability of getting 3 or more? See, I don't want to be lost in the calculation, but what I'm clearly seeing is I have improved my chances by counting picking a bigger range. I'm saying that, okay, if I'm rolling to get a 1, it's 1 out of 6. I may or may not get. If I'm betting my whole wealth for getting a 1 in 1 roll of the dice, I might become bankrupt. But if I am keeping the option of, if I have a range, say, okay, fine, you can still win or save your wealth if you are getting it in 3 or more. That means these are the 4 options that is possible. Only these 2 are ruled out. So 4 out of 6 is my probability. So Here what happened actually, I picked up the probability of 3, which is 1 by 6, plus 4 plus 5 plus 6. What I'm doing here, I'm just adding all the probabilities. Yeah? Probability of multiple things together, I'm just adding them together. And they are still mutually exclusive. But, everybody with me? Yeah? What happened? Something interesting?
His calculator fell.
Oh, that's okay. Alright, so here what we are seeing is, this is a classic example of adding probability for 3, 4, 5 and 6 together. We just added 4 mutually exclusive probabilities. Yeah? But there is one more scenario. Is this if somebody says, find out the probability of A and find out the probability of B, and what will be the probability of A or B? Basically, I'm adding 2 probabilities together. Can I simply add them together, or there is some more thing that I have to take into consideration as a generic thumb of rule or rule of thumb? I'm not sure if I stated the question correctly or not. So here we are talking about adding probabilities, meaning I have probability of a certain thing, I have probability of another thing. If I have to add the probabilities, as a generic rule, we saw it happening. I mean, we saw it mutually exclusive events and we added them together. Do I have a way to generalize this understanding? Let me give you guys something to ponder, and then we'll break it down. If I have, let's say, probability of A or B, and let me write it like English. Probability of A or B, one thing we saw was we added the probabilities. Probability of A plus probability of B. I'm wanting to come up with a very generalized rule. What I will do is, I will say probability of A and B. Now this is taking a twist. Anybody, if you want to tell me what I'm trying to get to. Let's see if any of the student is ahead of the teacher right now. So this is where a Venn diagram comes into picture. This Venn diagram is that, see, when you talk about probability, you are essentially talking about the total probability of a given event divided by the total number of events. That is the basic definition of probability, correct? Yes or no? Dhanushri with me? They with me as well? Okay. So this is my total number of probability, okay? Now within that, let's say this is a probability of getting this is a probability of rolling a dice. This is total number of probabilities, meaning 1, 2, 3, 4, 5, 6. This is probability of, or I'll say this is the probability of getting 1, this is probability of getting 2, this is probability of getting 3, probability of getting 4, this is 5, this is 6. Yeah? All these probabilities are getting added together to make the total number of events. Now, giving a little twist to this, let's not worry about 6 different events. Let's talk about a scenario where I am using a Venn diagram to represent the total number of students, okay? This is my total in a class. Let's say 10 students, 100 students, okay? This is the number of students in the class. Out of that, I'm saying this is the number of students who likes math. I'm only doing a survey between math and science right now, okay? So out of 100 students, this is the number of students who like math. Let's say this is 60. And I'm saying there is another circle representing the number of students liking science. And this is also 60. What happened?
the number of people who like math and the number of people who like science doesn't equal the number of students served?
Because most of the students, it's not mutually exclusive. There will be students who like math and science both. So the drawing I made here, it pretty much aligns with my drawing skills. My drawing skills are really bad. I have to make corrections to that. And it has to go like this. Because you have certain number of students who like science and math both.
Wait, so that means there's a probability that all of them both like math.
I mean, I'm not going there. I'm assuming that will not be the case. I hope that is the ideal scenario when in a class you pick up 50 students and everybody is equally good in math and science both. I wish that happens, but not a great idea, I would say. If everybody likes one subject, imagine a situation when there's a crisis of job with a particular skill. Either everybody will be employed or everybody will be unemployed. So you have to have diversity. There is a very important role diversity plays in every aspect of life. Imagine if we all look the same. Our parents will have so much of hard time recognizing who is my child. Correct? So diversity is very much needed in practical sense. So coming back to the actual discussion here, this is my Venn diagram which is representing. This is based on a survey of 100 students. 60 students like math, 60 students like science, and I have surveyed all 100 students. How come this is 120? Because there are 20 students, unlike me, who like science and math both. So that is how there are a couple of things that we can interpret from this diagram right now. One thing is, event of a student liking science versus event of a student liking math is not mutually exclusive. This is that A and B part. Intersecting part, that is common here. So, if you look at the sum of this class, you will say, okay, fine, A or B's, math or science, includes this circle and this circle together. And if I count this circle and this circle, you saw that, okay, total number of students were 100. If I count them separately, it becomes 60 plus 60, which is 120, which is wrong. Because we have discounted this part. So any union operation that you talk about or any addition of probability you talk about, keep that in mind. This is going to be a formula. That probability of A or B equals probability of A plus probability of B minus probability of A and B. Probability of A plus probability of B minus this, because if you are counting this shaded portion in this circle, you are not supposed to count this shaded portion in this circle also. Otherwise you are double counting this common area, isn't it? This common area is your A and B. Now you relate that with the concept of dependent and mutually exclusive event. If you are talking about mutually exclusive event, meaning this area will be 0, then you can as well count them as sum of the two. If you are talking about related event or dependent event, that is where this probability of the common or the dependent event has to be subtracted from the sum of this to get you the probability of A plus B. That is what Venn diagram teaches us. Is that part clear to everybody? Dev, Dhanushri, Shiv?
Yes, sir.
Clear? Okay. Now this is all the talking that I had to do. Now let's look at some of the concepts. So first of all, let's quickly relay back what are the things that we have looked at. We re-emphasized or re-looked at what is the concept difference between dependent and mutually exclusive event. That is one. Second thing we looked at was how do you find out the sum of two probabilities? Yeah. A or B, we found a generic rule where we can apply that rule or that formula for calculating the probability of a combined event as A or B, meaning when you are trying to sum it up, you'll have to just discount the common part. If it's mutually exclusive, the common part is 0 itself, so you don't have to worry about it. If you're talking about dependent event, you have to discount that from the sum of the two events. This is the probability addition part of it. Now the third thing that we learned was the probability multiplication, where we saw, okay fine, I have an event A, then event B, and then event C, all probability A, probability B and probability C. If I have to look at the joint, look at the probability of all of them happening together, I have to multiply this probability with this probability with this probability, and that's how I get the combined probability. That is what we saw in case of tossing 2 coin versus 3 coin versus whatever. Yep. Now let's look at some realistic problem. Otherwise you'll end up relying only on the blabbering that I am doing right now. So let's look at some problems that you guys can relate to. Alright, so let's look at some of the problems. I got a little distracted. I thought one of the kid was trying to join. So let's look at some problems real quick and see what kind of a situation that you guys will end up dealing with, and are we mentally, physically, emotionally, socially prepared to solve them. Let's look at it. I'm not sure if you guys deal with your dad jokes at home or not, but I have a very bad habit of cracking dad jokes. Okay, my kids are tired of it, and you guys are the extended victim of that as well. Okay, so I'm just drawing something that was there in one of the questions, and we will probably not try solving it. We'll try digesting these questions and try putting our thoughts around how do we read a problem, how do we interpret that, and how do we approach a problem. Okay, so here let me first do the writing work. Dye, haircut, permanent. Okay, and then this is 5%, this is 30%, this is 35%, this is 10%, this is 5%, this is 15%. Okay, now let me read the question for you guys. I hope everybody can see what is there on the board, right? There's a Venn diagram with 3 circles in between, and we see some overlap among those circles. And this is called dye, this is haircut, and this is permanent, probably hair implant. And interestingly, all these 3 things are out of syllabus for me. Neither I do dye, nor I go for haircut, and permanent hair implant is anyways out of the equation. So let me read the question for you guys. A salon owner noted what type of services its clients requested last week. Here are the results. So this Venn diagram is actually representing the view of what a salon owner observed. In this sample, are the events dye and permanent mutually exclusive? That's the question. First circle is dye, second circle is haircut, third circle is permanent or hair implant, whatever it be. This is 5%, this is 30%, this is 35%, this is 10%, this is 5%. The question that it asks is, in this sample, are the events dye and permanent mutually exclusive event? Am I making you sleepy, Sev? What is the answer here? I heard some answers here in the classroom. I am interested in hearing from one of you as well on the screen. Are this event and this event mutually exclusive? Just by looking at the picture. Yes or no, Dev, Dhanushri, Shiv?
I think they are, sir.
I'm sorry?
I think they are, because they're not overlapping.
Exactly. they are mutually exclusive only. As soon as, if you see a diagram, okay, no matter what is there in the diagram, if you're talking about this event and this event, there is no correlation, there is no connection, there is no overlap, there is no linkage. Mutually exclusive, no matter who says what. Yeah? So we solved one problem in 30 seconds, and only because the way they explained and the way Arush nodded his face without saying a single word, I could get what he's trying to convey. He said, are they mutually exclusive? Arush said yes, without saying a single word. And that, see, that's my motivation also, right? When I talk to you guys, when I am able to make eye contact, I know what is in your mind, okay? I mean, not that I can read mind, but at least I can interpret. Okay, let's go to the second question. And this is going to be a word problem, okay? A big paragraph for a very simple question. Let me read this for you guys. Everybody here. A civics teacher asked her students to indicate whether they believed each of the two headlines. One last time. A civics teacher asked her students to indicate whether they believed each of the two headlines. Okay, this is only blabbering. Let's go to the next line. One headline was false and the other one was true. Okay, there were two headlines. One headline was false and another one was true. But the students did not know this. The probability that a student selected a random believed the true headline was 90%, and the probability that the students believed the false headline was 82%. She found that 75% of students believed both headlines. Too much of a story, okay? Let me read it one more time and I'll draw it as I speak. First line not covering, okay? The teacher just believed students to, requested her students to believe in two headlines, okay? One headline was false. Let's say this was 1. And the other headline was true. I'm just assuming that there was some overlap, okay? Let me see what it translates to. The probability that a student selected a random believed the true headline was 90%. And the probability that the student believed the false headline was 82%. She found that 75% of the students believed both the headlines. So this is 75%. In this sample, are the events believed the false headline and the believed the true headlines mutually exclusive? So, let me not read it one more time, but if you look at the diagram or whatever I kind of squeezed from the question, it said 90% of the headlines were supposed to be or believed to be true by students, okay? She asked all her students to go through the two headlines and they assumed headlines to be first, one of the headlines to be 90% the students believed that the headlines were true. 82% of the students believed that the headlines were false. And 75% of students believed both were, 75% of students believe that it's true and false both. Okay. So the first part of the question says, in this sample, are the events believed the false headline and believed the true headlines mutually exclusive? Are they mutually exclusive? As soon as you see an overlap, as soon as you see there is something common, as soon as you see that there is something that is not completely disconnected, they cannot be mutually exclusive. Shiv, are you getting stressed out with that? No? Yes?
No, not really.
Okay. If you want to get a glass of water, that's fine. I mean, sometimes I get a little boring, but yeah. All right. So, a summary of what we have done so far is just waste of time. We have just looked at how do we relate connected or dependent events versus mutually exclusive event. And that is with the help of a Venn diagram. It helps us reaffirm whether two events are mutually exclusive or related. Okay, and for you all to be aware, after the class, when you want to kind of relook at what we learned and am I able to solve the problems relating to that concept, I would request you guys to go to Khan Academy. In Khan Academy, go for math, high school and college classes. Underneath that, you'll find pre-calculus. Go to pre-calculus and then unit 8, if I'm not wrong, is probability. That is what we are doing right now. So within that, I would want you guys to just don't go through the study material because that's what we are covering right now. If you want to test whether your teacher is teaching you the concepts in an efficient way or not, straight away jump onto the unit test for that particular topic and try doing it without having to refer anything. If we are able to do a justice with the conceptual part of it, you should be able to solve it. If we are not, that will also get exposed and that will give us another chance to go through the concept one more time or challenge the teacher that okay, you are wasting my time. Okay. Is that okay? Would you guys ever have the courage to say, teacher, that you are wasting our time? I would say don't be shy. If I do so, one class is understandable. If I do that in multiple classes, don't waste your time. Your time is more precious than the time you spend with me. Okay? If we are not learning something fruitful, meaningful, show that courage. If you cannot tell this to your teacher, tell it to your daddy, our parents. Yeah. All right. Let's go on to the next part. Now, next question. Okay. Now, this will be a little interesting. I'm reading the question for you guys. Okay. On a multiple choice test, problem 1 has 4 choices. Problem 1 has 4 choices. It's MCQ. Right. And problem 2 has 3 choices. Okay. Each problem has only one correct answer. What is the probability of randomly guessing the correct answer on both problems? See, this is interesting and very relevant, right? Sometimes we go underprepared or unprepared for exams, right? I mean, I'm not sure about you guys, but I have gone through that situation multiple times. This question says that you had everybody here. See, I'm not really interested in the answer, okay? Whether it's 0.2, 0.28, 0.26, I'm not really interested in that. I would want you guys to get this thing, kind of, tattooed in your brain. That this is my approach. Now, what the answer is, that calculator will tell you in time. Now, the problem is this. Let me read it one last time and then we'll try solving it. On a multiple choice test, problem 1 has 4 choices and problem 2 has 3 choices. Each problem has only one correct answer. What is the probability of randomly guessing the correct answer in both attempts? So, we are talking about making the right guess in this question and making the right guess in this question. It is as good as getting ahead in the first toss and getting ahead in the second toss. So basically what we did, we multiplied this probability with this probability and that gave me a combined probability. This is a classic example of multiplication of probability. Now, so we talked about the clue, right? So let me solve this for you guys. And I'm sure you guys must be thinking on similar lines. The question says there are 2 problems. First problem has 4 choices and only one is correct. So is the case with the second one. This one has 3 choices, only one is correct. So what is the probability that if somebody like your teacher who goes for the exam without being prepared and makes a blind guess for both the questions, what is the probability of getting both the answers right? Now here there are 4 choices, only one answer is right. So if I'm making a guess, my probability of getting it right is only 1 out of 4 for the first one. My probability of getting right for the second question is also 1 out of 3. If it's a lucky day for me, I might win a jackpot. Okay? But anyways, this is not up to jackpot. Coming back to this one. So, probability of getting the right answer with a blind guess is 1 out of 4. probability of getting a right answer with a blind guess is 1 out of 3 for the second one. What is my combined probability? What is my probability of getting both my questions right? 1 by 4. Done deal. 1 by 12. Whatever calculator says is what you can believe. But how is what we should be very clear about. Is that okay for everybody? Is everybody with me so far? Okay. Dhanushri Dev. Sahit, I have not even asked you. Okay, so far? Okay. Alright. Let's pick one more question and then we'll go to something called permutation. Okay? I had mentioned that we'll learn permutation and combination along with these concepts, but there will be a little bit of too much. Let's look at this one, this question. Maya is playing a trivia game with multiple choice questions. Maya is playing a trivia game with multiple choice questions. Each question has 2 correct answers. This is Maya playing trivia game. Okay. Each question has 2 correct answers among 5 answer choices. So each question has 2 correct answers. I'm just noting it down, okay, because among 5 options. Maya has no idea what the answers to a certain question are. So she needs to choose 2 different answers at random. What is the probability that Maya's first guess is correct and her second guess is incorrect? Let me read the question one last time and then I'll let you guys struggle with it. Maya is playing a trivia game with multiple choice questions. Each question has 2 correct answers among 5 answers. So there are 5 choices among which you have to pick 2 which are correct. Maya has no idea what the answer for a certain question are. So she needs to choose 2 different answers at random. What is the probability that Maya's first guess is correct and her second guess is incorrect? Yep.
To get the question right, do you need to select both correct answers or only one?
So
No.
it's a question. See, you would have seen MCQs
Yeah.
where, let's say this is a question and you will see, let me talk in terms of what you guys are comfortable with. You would have seen that, okay, you have like one option to choose, or you would have seen where you can choose multiple options when there are more than one answer. So here the example is you have 5 options to choose from for one question and there are 2 possible answers. There are 2 correct answers. Means you have to pick 2 choices among the 5.
So you need to put both together.
You have to pick 2. So the question here is, what is the possibility of the first choice that she made is correct and the second one is incorrect? This is a good example. And this should make you guys think. Dhanushri, Dev, Shiv. So I would need little more than a thumbs up, Dhanushri. Tell me, what is your approach, beta? And don't try solving it. Don't give me the answer like 2.8 or 1.7, 0.79. I'm not looking for that. Tell me, how will your brain process this solution? How would you approach this? How will you tell that story to somebody who doesn't understand things much?
So you have to do 2 out of 5.
Now, just 1 second. Dhanushri, I'm not able to hear you, beta. Can you try, Shiv, can you talk a little bit? Can you just unmute yourself? I'm just trying, okay. Can you hear me okay? Okay, yeah. So I think, Dhanushri, it might be a problem at your end. You might want to discontinue and join back again. Disconnect and join back again. Yeah? Just 1 second. Yeah, sorry. Please.
Okay, so first you have to do 2 out of 5 because there's 2 correct choices out of 5.
Mm-hmm.
And then you have to multiply that with 2 out of 5 again because you need to pick the, or no, 1 out of 5 because you already picked the 1 and you need to get the other one. No, 1 out of 4. So 2 out of 5 multiplied by 1 out of 4 and then you multiply that by 3 out of 5 because for the next question, which is the amount that are wrong. And then that's how you get the answer.
Okay, no, you're thinking in the right direction, but I will not tell you whether it's correct or not so that I don't get others biased. Let me read the last line of the question which says, what is the probability that Maya's first guess is correct and her second guess is incorrect?
Oh.
Okay, now Dhanushri, are you able to speak now?
Are you able to hear me now?
100% better. Okay. Now tell me what is going in your mind. Tell me how do you approach?
First, try to figure out Maya's guesses, and then using that data, I would figure out like what if her first or second guess is right, if that makes sense.
It does. So the question says, what is the probability that Maya's first guess is correct and the second guess is incorrect? So I heard something from Davik and I'm wanting to hear everybody else's opinion as well. Yes, Arush, tell me what is going on in your mind.
So to find the correct answer, the first is 2 out of 5 times 2 out of 5 because
No, first guess for the first
first guess.
For the first answer.
First guess is correct
First
and
guess.
second guess is incorrect.
Yes, but you have to multiply both ones. So to get the first guess itself, you need 2 out of 5 times 1 out of 4 because you first select an answer. The next one you can't select the same answer again, so it's -1.
Okay.
And then since you already selected the correct answer, there's only 1 correct answer left. That's 1 out of 4. So it's already.
I'll come to you, Davik. I know
And then
something is
Next is the
flickering
wrong
in your
answer.
mind.
Next is the wrong answer.
Uh-huh.
So for the wrong answer, you need to do 3 out of 5 because 3 are wrong. And the next one you have to do 2 out of 4 because you can't select the same answer again, and you can only have to select 2 because you can't select the same answer again. So you just multiply those 2, and you just multiply everything.
okay.
That's it.
He's
Okay, so I'm gonna fix mine. It's actually because you said first guess and second guess. It's the one question, right? And it's first guess. Okay, so that means that first it's 2 out of 5, and then you have to multiply it by 3 out of 4 because that means there's one question, one correct answer, and everything else is wrong. So that would be 3 out of 4 because they're not mutually exclusive. They're dependent on each other.
Okay.
On the same thing process.
Same thing, always. Okay. Dev, Shiv. I've heard everybody, but I've not heard you both.
And then also the answer. If you do it my way, it's 3%.
How much?
3%.
30%. Okay. We'll come back to the answer part also. Yeah. Dev and Shiv, tell me your thought process at least. Solution we'll figure out.
Would it be 2/5 times 1/4 because selecting the first question is 2/5, and then if that was correct, then times 1/4 to get both correct.
Okay, so I will repeat my last part of the question one more time. It says, what is the probability of the first choice being correct and second choice being incorrect?
Then that would still be, then that would be 2/5 times, 2/5 times 3/4.
Okay. Dev, how about you, beta? Dev is not happy with me today, not wanting to talk to me.
Hello, sir, do you hear me now?
Yep, I can.
Okay, sorry, my internet was acting up.
Okay.
Wait, sir, can you repeat the question one more time? Sorry.
So the question is that it's a multiple choice question where there are 2 right answers. So Maya, who is a student who is attempting a blind guess and has chosen 2 options. It says, what is the probability of Maya getting first answer correct and first option correct and second option being incorrect. So don't have to solve it, just tell me how would you approach it.
Okay, so it's out of 5 questions each, right?
No, so basically it's one question which has 5 options and there are only 2 options that are correct.
Oh, okay. So I would say the probability of Maya getting a correct answer from 5 things is 1 out of 5, because for her to pick a correct answer out of 5 options. Wait. Oh no, sorry, it would be 2 out of
2
5.
options actually, 2.
2 out of, yes,
Yeah.
because there's 2 correct answers. Sorry, yeah.
Okay. So now let me do it like a child, because I miss my childhood days. Okay, all right. It's been long since I have passed that stage. So here the question is that this is a multiple choice question, and there are 2 answers. So it's like picking. Look at this. These are the 3 incorrect answers and these are 2 correct answers. Okay, and the size of marble is also the same, probably. That's why just by touching it you cannot figure out. So the shaded ones are the incorrect answer and the transparent ones are the correct answer. When Maya picks up one of this thing which is correct, obviously she is picking 2 out of 5. She picked up 2 out of 5. One of the correct answer is gone. What she is left with? 3 incorrect, 1 correct. What is the probability of she getting the incorrect answer in the second pick?
3-4.
It's 3 out of 4. Which becomes
6 over 20 or 310, yeah.
0.3 or 30%. So I heard different versions and all of you were correct in your approach. This is something that I don't really care about, because if you have come to this point all the way through with the right approach, you will get it as a byproduct. So that's why in every class I say that I don't really care about the answer. That doesn't mean I have no respect for the answer. What I care about is the approach. If we get this approach right, we can solve hundreds of problems of similar nature. Okay, so that's why I put less emphasis on answer and more emphasis on the approach or the solution technique. Yeah. So whenever you guys hear me out saying that no, I don't care about the answer, that doesn't mean that I'm rude or arrogant. I'm just loving this part more. Yeah. Is everyone with me so far? Now, permutation and combination. This is something that used to haunt me when I was your age. Okay. Permutation and combination used to literally haunt me. What happened? No. So okay. So let's not rely much on my story. When I say it used to haunt me till I had not kind of broken my head with this. Okay. And what I mean by that is, any problem, any concept that you try solving or learning, you have to make sure that you're able to relate that with your real thing here. Let's look at the situation here. In the classroom, I have 3 kids: Arush, Daivik, and Sahit. Okay, and I have 3 chairs here. And every position or every chair has a number to it, and like every child has a name to it, right? So, and you guys don't feel bad, right? If I call you child. All right. So I have 3 chairs in the classroom. I have 3 kids here. Every kid has a name. Every chair has a number, and there is a sequence. If I put Sahit on chair 1, then I'm left with only 2 options to pick from when I have to put where I have to put Daivik or where I have to put Arush. But for the first chair, I had 3 options. I could have picked either Sahit, Daivik, or Arush. So let's say this is my chair 1. If it doesn't look like chair, bear with it. Let it be. Okay. This is chair 1. Pretty good. It looks like a chair. So this is something that I had a lot of doubt about. Okay, my drawing skills are horrible. Okay, so these are 3 chairs. And we'll be done in 5 minutes, okay? I'm just going to emphasize on the concept and then I'll let you guys go. And we'll deal with permutation combination in more detail in the coming class. So I have 3 chairs, A, B and C. If I have 3 kids to sit on this, let's say this is Davik, this is Sahit and this is Arush. So for the first chair, if I had to pick one person, one child, I had 3 options. Let's say I picked Sahit. Then after having picked Sahit, for the second chair, I was left with only 2 options, either Arush or Davik. Let's say I picked Arush. For the third chair, I had to do a musical chair with Davik only. So I had no other option but to only give it to Davik. Okay, this is not sad. So here, what we see again, these are related events. They have direct linkage with each other, and we have to find what is the probability of making the kids sit with the option that we have. It's 3 times 2 times 1. This many options we have. This many ways I can make the 3 kids sit on these 3 chairs. This is what is called 3 factorial. If I have 5 chairs and make 5 kids sit on that, I had factorial 5 options. Because you will see that every time you pick a chair and a child, you are left with lesser number of options, and it keeps on reducing by 1. So that's what this factorial is. If you're talking about factorial, n factorial, you're talking about n times n minus 1 times n minus 2 times till you get to 1. Okay. And I have one. Okay, leave it. I will stop here so that you guys don't feel hungry and stressed about today's class. With whatever we learned today, was that an okay recap? Was it a good learning experience, or there's something that was not clear?
Very good.
Okay, thank you. So with that being said, I will let you guys go. Have a good dinner, a good night's sleep, and I'll come back to haunt you next Wednesday again. Yep. All right. I said I'll come back to haunt you guys, and then Siva say okay. I'll not haunt you guys. Okay, don't worry. Okay. Good night, everybody. Take care. All right. Bye bye. Bye bye.
Thank you, sir.
Yep. Bye bye.
Leadership.